Hi, welcome to the Module 4 of Data Migration Framework course. I am Krupesh Desai, your trainer for this course and the author of the book Data Migration Framework. In this training, we will learn about the data migration testing strategy. We are now in the third group of the framework that includes three components. In the last session, we looked at the significance of planning multiple test iterations before the actual go live. Let's look at what we need to test in each iteration and what our testing strategy could be to eliminate all unpleasant surprises from the data migration process. Testing creates trust and confidence in the end to end data migration process. Improvising testing capabilities with each iteration should be the logical way to progress and gradually improve the data migration success ratio. Many organizations treat data migration testing as a one time validation step rather than a continuous feedback cycle. In reality, you should repeat test iteration until full confidence is achieved in the data migration process to do the big job on the cutover day. In each iteration, data migration stakeholders go through the cycle of analyze, refine, retest, and improve. Think of data migration as creating a statue. You don't carve everything in the first go. You chisel, refine, step back, and adjust. This is exactly how you do data migration as well. Skipping testing iterations is like releasing a half finished product into the market. It will break. Therefore, it is essential to foresee and mitigate any potential problems or glitches that could occur during or after the data migration. Thus, I place the testing strategy as a critical part of the data migration framework, which must be articulated in the data migration plan. I recommend a testing strategy covering three types of testing to ensure the best possible data migration, and that is data unit testing, data integrity testing, and finally the functional testing. Let's look at them one by one in the next slides. By data unit testing, I refer to validating data migration process for individual data sets, often referred to as business entities. The name is inspired by the traditional unit testing associated with testing each unit of function within a computer program. The data unit here refers to the logical segment of the target data structures, such as customer, patient, customer address, appointments, orders, etc. They are the business entities, as I said. And therefore, unit testing refers to testing data extraction and transformation logic for each target data structure, and that too in isolation. Unit testing ensures no data loss due to logical error in the data migration code or invalid orchestration of the ETL process itself. Data unit testing requires a comprehensive audit trail for each step of data migration across every target data structure. For instance, when migrating patient or customer data, the unit test would include checking and comparing the number of records extracted, transformed, loaded, and rejected for the patient and customer entity. It is not always a one to one match due to merge or removal of duplicates or even rejection of data because of data quality issues. Through data unit testing for all target data structures in migration, The project team can ensure that no data loss can occur due to glitches in the data extraction and transformation code, especially in derived data attributes, where value is calculated during data transformation. For example, the data migration code for migrating customers from the legacy system should generate audit trail information that X records of customers are extracted from the legacy system, Y number of records are loaded in the target system, while Z number of records were rejected, and grouped by multiple rejection reasons, which could be duplicates or invalid entries, poor data quality, but it should keep a log of every data that is extracted, transformed, or even rejected during the transformation. In nutshell, the objective of data unit testing are simple. It ensures that the correct number of records are extracted and loaded, considering any merge or removal of duplication or data quality rejection. It also monitors for the discrepancies between extracted and loaded data, highlighting where the data fails to meet data quality standard. And the third is to track the total count of records processed, rejected, merged, and ensuring the traceability of every transformation. Here is an example of the outcome of the data unit testing. For every iteration, once your migration is matured and you start capturing logs, here is an example that every time you run an iteration, the data migration test iteration, you should capture this information. And this is the first layer of information. You should also have fine-grained logs that will tell you why a certain number of records are rejected in the migration. Every time you run the test iteration, you should have these numbers in your hand. And you should be able to explain why certain records have not made into the target system. After data unit testing comes the data integrity testing. Data integrity testing ensures that the relationships between business entities in the legacy data remain intact post data migration, and the final stage data is fit for the migration. Data integrity testing is conducted on the final staging dataset prepared for that one final load into the target system. It is done by executing an audit script. This audit can run through all integrity checks on that target dataset and highlight those particular data records that violate one or more mandatory conditions. For large transformation projects, it is a reasonable expectation from the vendor to either provide such audit mechanism before the data is uploaded or provide the necessary information to build one data integrity audit script that conducts a series of checks on the final data set prepared for the migration. Integrity testing through audit scripts is a must before the final data set is pushed into the target system because it ensures that migrated data is coherent and contains all data points comprising a business transaction in the target system. A comprehensive audit script should also ensure that all mandatory attributes required by the user interface are present in the final dataset to prevent any unexpected errors in the target system during its operational use. For example, no order record can be loaded in the target system without the customer record already available who placed the order. Similarly, no appointment or booking information can exist without the corresponding patient record. Employee record must have a valid team identifier of a team already created in the target system. So the objective of the data integrity testing is to make sure that the data is consistent across the entire dataset prepared for the final load. The data relationships between these datasets are intact and highly accurate. It also ensures that there are no orphaned records or incomplete relationships that could impact the functionality of the target system. So, the objective of the data integrity testing is to ensure that migrated data is highly accurate, integrated, complete, and trustworthy. After the integrity testing comes the functional testing. This is where the rubber hits the road. Functional testing verifies that migrated data functions as expected within the context of the new system. It involves testing real world use cases to confirm that legacy data interacts seamlessly with the new application without breaking any existing processes. One key aspect of functional testing is processing open transactions that were migrated from the legacy system, such as discharging a patient who was admitted when the legacy system was operational, or dispatching goods for a sales order captured in the legacy system. Another critical function area to test is ensuring upstream and downstream integrations work in the target system with the migrated data without any glitches. Functional testing of data migration can be combined with system integration or user acceptance testing, which are part of the larger change and part of the test plan for deployment of the new business application. So check with your project manager and the program manager and work on the possibility of integrating the data migration functional testing with user acceptance and system integration. Therefore, the planning of the functional data migration testing needs careful considerations. It needs a dedicated test environment and resources for testing with the real world data, which may have regulatory constraint preventing its use for the testing. So you need to liaise with your compliance and legal team as well when planning for the functional testing, especially when you want to involve the real user data. Secondly, you can only test some migrated records out of the millions migrated overall. Therefore, a relatively tiny number of records are to be selected as a random sample size for the functional testing, and that should ensure 95 to 99% confidence in the testing. Calculating this sample size is a very critical step, and it requires balancing statistical confidence and practical feasibility. A common approach involves applying statistical methods such as random sampling to select a subset of record for validation. The formula for calculating sample size based on confidence level, margin of error, and population is a standard statistical methodology widely used in survey sampling. I would recommend this frequent citation from the book Sampling Techniques in case you want to know more about the sampling methods, including the finite population corrections and calculating sample sizes. For now, the generic guideline is determine your confidence level and margin of error and use this formula. So let's look at a quick example. If you are migrating 100,000 patient medical records with confidence of 95% and 5% of margin of error, you need to test at least 383 patient records. Now, after patient, you have appointments, wait list, inpatient visits, diagnosis, right? So numbers keep piling up. Or you can take this 383 patient and in the testing include all the related transactions. For example, a patient would have multiple referrals, multiple appointments, multiple inpatient visits, multiple diagnoses. So when you're comparing 383 patients, you have to consider this related transactions as well to be comprehensive in terms of your functional testing. Now use this formula and try to calculate sample size when migration scope is 1 million patient records. And we need to achieve 99.99% of confidence level and only 2% of margin of error. The number would be huge, but it will ensure that your testing is comprehensive. However, comparing that many patient records is not feasible. So therefore, when selecting the right sample size, the ideal range is to go with the 95% confidence level and 5% of margin of error. But if you have resources and you want to go with 99.99 confidence, go for it. Despite having a small amount of data for your initial test iterations, I would recommend to incorporate functional testing as soon as possible in your iterations. If you're only migrating one type of data, let's say you're only migrating patients or customers' master data, try to compare them on your legacy and the target system as soon as possible. That way, all the potential issues will surface sooner, all the showstoppers will come out as well, and you will have enough time to react, report, and eliminate that issue. Incorporating functional testing early on in your iteration will eventually maximize your testing scope. You are not parking your testing for the last moment. Rather, you are testing as you progressing through iterations, and you have enough confidence in your data migration processes, and that would enable you to go with the lower confidence level and a higher error of margin to be ensured that the final data migration testing you are doing, the functional testing, it's good enough for your migration because you've been testing throughout the iterations. So, in a nutshell, the objectives of functional testing is simple. Once the legacy data is in the new system, the functional testing will ensure that all transactional data is visible and behaves as intended with the real scenarios. It will also confirm that the new system performs as expected in your daily operations. It ensures that the migration process has not altered or lost any data by comparing the migrated data in the legacy and the new system. And it will also ensure that the end-to-end data flow is functional and working without any glitches, ensuring that all the upstream and downstream integrations are working as expected. When you go through multiple iterations, you should eventually build trust in your data migration process. And this 3 layers of testing is your feedback loop to reject as much invalid data as possible at the early stage. What I mean by this, after your first or second iteration, you find certain issues, functional issues, you should improve your audits for the integrity testing so that data is rejected at that layer. The data being rejected on the integrity should be further identified during your data transformation process itself so it can be reported back to the user for fixing, and you are rejecting it during the data migration. So the clean data comes out, or only the clean data comes out from your data transformation, which is then go through the audit for ensuring integrity, and that would eventually go to the functional testing after the load. What it will do is the data that ending up in the target system becomes more and more reliable. You are rejecting all potential bad records in these two layers of testing. And with the multiple iterations, you need to reduce that number of issues. So the throughput and the amount of data making him in the target system after few iteration would be trustworthy and reliable. As you know the drill by now, here is a set of questions from this component. Have a look. By breaking down data migration testing into data unit, data integrity, and function test, you can ensure the accuracy, reliability, and performance of your migrated data. Each testing type helps you to address potential issues before they impact your new system and the business continuity. Ensuring all testing is iterative and integrated in your migration plan will lead to a smoother transition with fewer surprises on the go live. Thank you for participating in this training. I hope you are equipped to plan a robust data migration testing for your project. Please continue on the next video on the go live planning. Thank you.